Hello, Daftman here again. Hope that's in focus for you. I can't tell with this little monitor of mine. Now this is my temporary setup, Newman motor. Sorry about the untidiness, but it is only a temporary setup just to show one of my YouTube buddies that I'm corresponding with over YouTube. His name's Bill, so if you're out there, Bill, hi. Now, there is 200 feet of wire, 0.71 millimeters, wound onto two coils at 100 feet each. Yes, we've got a relay, and we've got a reed switch that triggers the relay that obviously supplies power to the coils. Flying little magnet, as you can see. It runs on 24 volts, and we've got north-south poled magnets in there. Can't turn it too far because the thing will try tripping on me. But there we go. Oh, I haven't got the power on, so it won't. Now, as you can see, normally that there would go straight down to the coil. I've left them this long and untidy for a reason, as I'll explain to you in a few minutes. So what we'll do now, will this run without a commutator? Well, the answer to that is yes. So we'll just boot everything up. So I'm just working with my other hand, trying to do this in one take. Now we're just going to flip around to fire position, and that's it. Now she's doing 4,700 RPM when I last tested it, and that is the voltage and the current. Now we're running 200 milliamps. It actually runs normally a little tiny bit under that, about 150 milliamps. And we are on about 22.5 volts. I think that meter's a little bit out actually. I've only bought these today and I've not had a chance to calibrate them or test them or anything yet. So there we go, and you can see we're actually dropping just under the 200 milliamps now. That's a 3 amp DC meter. Now the reason for the relay, because this could all be done with electronics, as I wanted to show you a peculiar effect. I've seen a lot of people that's built Newman motors, including Bill, but he only uses half the coil. He says he can't understand the need for the top one. Well, I'm just about to demonstrate the reason for it, or why it was built like that. Mine is a 2-part coil. What I want you to do is listen to the relay, to the speed. So if you're out there, Bill, this is for you. I'm sure you'll agree that's dropped half its revs. It was doing 4,700, and when I took a reading with this off, it went down to 2,350, I think, which was virtually half speed. Now, even if I took that out of the circuit, the speed doesn't go up. If I take this other coil out, the speed doesn't go up, it remains the same. Even if I adjust the timing, I cannot get that speed back up to over 4,000 revs. Other peculiar thing is this. Don't know if you can see that. The amperage has actually doubled. So we've actually doubled the amperage. Now, that is explainable, but I don't want to go into depth, because the idea of this project that Bill's doing and the rest of the group is the most economical motor they can produce with the maximum amount of speed and torque. Now I'm going to put it back on, but as you can listen, well, shut up. I'm sure you hear that jump back to speed, and your amperage has come back down again, look. But there's my attempted a Newman motor, so I think that's it because we're running up to about 5.5 minutes. But I think you will agree that is a successful Newman motor running without the commutator or dangly wire bit, as I've heard people call it. And the next step in this, I'm going to change all this arrangement round here, get rid of that, change it for a transistor circuit. We may actually have another coil in the top there to switch the transistor, or we may actually use a MOSFET.